Hello everyone, welcome to Learning Bits and I'm Santosh, and today we are going to discuss the Cohen-Sutherland Line Clipping Algorithm. Fine. So now just look at this. When we're going to talk about the line clipping algorithm, so usually it's going to be a two-dimensional line clipping algorithm, and this Cohen-Sutherland line clipping algorithm is usually used for 2D or two-dimensional clipping itself. Fine. Now just look at this sort of lines or this sort of examples. So the line 1, which is going to be the point 1 and the point 2, and one more line, the P3 and the P4, and similarly I'm going to have this 5 lines using the 10 points, and whatever the red dashed lines you are seeing, this is we're going to call this as the clip area or the clip region. That means whatever the object or the lines or the part of the lines is going to be inside this area should be displayed and should be visible, and whatever the part of the line or the whole line which is going to be outside this region will be clipped off. Hence we are not supposed to display this. We need to reject these lines from the view, and that is what this Cohen-Sutherland line clipping algorithm is going to do. And so now we will see exactly how this algorithm should be used and how exactly we are going to make use of this, so that we are going to check out what are the visible parts, either the whole line, something like this, or the part of the lines, something like this, which is crossing a single edge, or even if it crosses 2 edges, or if it's going to be completely outside the clipping area. We are going to discuss about all this sort of lines, and we'll see how efficiently we are going to make use of this algorithm whenever we're going to clip out the lines which is going to be not displayed or which should not be displayed. Hence in this term, whenever we're going to talk about a Cohen-Sutherland line clipping, so even before this there were few algorithms. So those algorithm was not efficient as comparatively right now with the Cohen-Sutherland line clipping algorithm. At this current era, you may have came across other type of line clipping algorithms, but this was the earliest algorithm which has been developed as or to be considered as fast line clipping. Fine, this was the earliest or the first algorithm which we can call this as fast line clipping algorithm. Hence we'll see how exactly this has been built. When we're going to talk about a Cohen-Sutherland line clipping algorithm, the major part of this is the region code. We are going to develop, or we are going to compute, or we are going to calculate, or we are going to assign a region code. So this region code is the main factor or the main block which is going to be used by the Cohen-Sutherland line clipping algorithm to work as a fast line clipping algorithm. Hence the region code, whatever we are going to use with the algorithm, is going to be a 4-bit code. So 4-bit. So just imagine a binary number which is be made of 8-bit or which will be made of 16-bit or any number of bits. But right now we'll focus on the 4 bits, the 4 lower bits. Fine. Hence the region code majorly, even though your variable is of 8 bits, it can work. Even it's of 32 bits, we can make use of that, but our main concentration is on the 4 bits of any variable, the 4 lower bits. And this 4 bits, whatever we are going to use, this is where we are going to put in the region values in the region code. Hence we're going to call this as region code. So right now don't imagine the variables and its memory and its byte size, the bit values. Don't imagine all those things. Right now when I say region code, it will be made up of 4-bit or the 4 bits of values. Hence we can even call this as 4-bit code. Hence we are going to have such way 4 bits. Behind this, let any number of bits be. We are not going to concentrate on that. We are going to concentrate on only this 4 bits or the 4 lower bits. Hence, so this 4 lower bits, what are going to have, the least lower bit, we are going to call this as bit 1. This is the bit 2 and bit 3 and the bit 4. This is the order what we are going to assign, what we are going to refer. When I say bit 1, this is going to be the lowest and the least lower bit, and when I say bit 4 and the least upper bit. Fine, this is how we are going to refer in our discussion or in this algorithm. So now what this all bit is going to make. So the bit 1, whatever we are going to say, we are going to call this as left bit, and the right bit, and the bottom bit, and the top bit. So now what is this left, right, bottom, top is going to be? That is, whenever you're going to consider a clipping area or clipping region, as you see in the earlier slide, it is going to be an area, a rectangle area. And when you talk about rectangle area, it has a left boundary, it has got a right boundary, it has got bottom, it has got top boundary. And these are the 4 boundaries which we are representing using this 4 bits. Fine. And so now using this region code and whatever the boundary we are going to have, now for this boundary, we are going to have left, we are going to have the right, we are going to have the bottom, and we are going to have the top. That is what we are going to assign. So now the bit whatever we are going to have now, the bit whatever going to have, we are going to depend upon the cases now. Fine. So now just look at this. This line, whatever the line you are seeing, we call this as the case 1. The case 1 because this line is completely inside the clipping region or clipping area, and this should be accepted totally. Hence we call this as lines completely inside and totally accepted. This becomes the case 1. And what can be the case 2? Yes, as you are guessing, a line which is going to be completely outside the clipping area, and this should be totally rejected. And now carefully observe here, carefully observe what is going to happen in this case. If it's case 1, it's clear, there is no any confusion. But in case 2, right now I have a confusion here. The confusion here is this line, I am calling this as case 2, which is completely outside and should be totally rejected. But even look at this line, even this line is completely outside. But right now I am not able to say it should be completely rejected, because we can clearly say using this algorithm a line is going to be completely outside only when it is outside the clipping region any one side. Either it should be at the left side, or it should be at the right side, or it should be the bottom side, or it should be at the top side. Any one side it should be totally out. That is, both the points of that line should be either towards left or towards right, towards bottom or towards top, with respect to saying the line is going to be out. But look at this line, one point is going to be at the top, other point is going to be at the right. As this is where we are not clearly able to say this line should be totally rejected. That is what the case 2 is. Line is completely outside, any one side should be, and totally rejected. Hence this I am not going to call this as case 2. And now the case 3, the line is partially or completely outside, crossing 2 edges. I can have a line which is going to be partially inside, crossing 1 edge, or partially inside, crossing 2 edges, or even without crossing any interior, it is going to cross 2 edges if I extend the line. If I'm going to extend the line, that is where we are going to say partially rejected right now. And so if I extend the right edge, if I extend the top edge, virtually, not physically, if I extend this, you can see the line is going to cross 2 edges. That is what a line is partial completely outside, crossing 2 edges, and partially rejected. So right now it's partially rejected. So later on it can be completely rejected or partially accepted. We'll see it later. But these are the 3 cases of the lines what you can see. If you draw any sort of line, those lines should fall into any one of these cases. If it is case 1, it is simple, just accept the line. If it is case 2, so it is still simple, just reject the line. If it is case 3, this is where you need to put in some computations, where we are going to compute the intersection of the line with the boundary, and we are going to check out which boundary is intersecting and what is the intersection new point is going to be to draw the line with the new intersection point and the whole other point. So this is what the Cohen-Sutherland line clipping is going to do with the line clipping process. So now we'll just take a single line and we will just continue the discussion, and we will see how this algorithm is going to work. The rest of the lines, you can think how exactly this algorithm is going to work. So now, before I start actually implementing this algorithm onto a line as an example, just look at this. I'm going to have a line, and we are all aware that a line is going to be made up of two endpoints. Similarly, the P1 and the P2. And when I say region code is assigned to each endpoints of a line. Clearly understand, the region code is not assigned to a line. A region code is assigned to each endpoint of a line. Hence, if I take any one line, it will be having two region codes for each endpoints. Hence, when I'm going to have these lines, P1 will be having its own 4-bit region code or region value, and P2 will have its own respective region code or region value. So now we'll see exactly how we are going to assign the region codes. Now I'm just going to take this clipping region. Now in this clipping region, whatever comes inside this clipping region should be accepted, and this becomes one region now. This becomes one main region. So now if I'm going to look into the entire scene of my design, if I look into entire my graphic system, this region is just a part of it. Hence, remaining all the parts, I can divide it like this. Find my entire screen, though this is going to be my clipping region, the remaining regions can be divided into other 8 regions. Hence, totally now I'm going to have 9 regions. This becomes the main region as a clipping region, and remaining 8 is going to be separate as left, right, bottom, top, and so on. Hence, we are going to call this region with the 4-bit as TBRL. I'm going to have again TBRL. So what is TBRL? It is top, bottom, right, left. It is top, bottom, right, left. Right now we are going to be in the main region, clipping region. Hence, we cannot call this as top. Even this is not bottom, not right, even not left also. It is center. Hence, I am not going to activate any side over here. But if I look at this, now this is going to be the left side of a clipping region. Hence, L will be activated. The left will be activated. Similarly, at this point, right will be activated. Now here, bottom should be activated. Here, top should be activated. So similarly, now if I look at this region, now what can be activated here? It is left, as the left bit should be activated. Even it is bottom, even it should be activated the bottom. Hence, this is going to be the bottom is activated, the left is activated. Similarly, you can just look into this bottom, right, and top, left, and top, right. Now, these are the 8 other regions what we are going to use. Clear? So now if we are going to have this, the bits, none of the side or none of this activated. Hence, the left bit is 0, the right bit is 0, the bottom bit is 0, and the top bit also is 0. And similarly now here I'm going to have 0, 0, 0, 1 because the left bit should be activated, right bit should be activated, bottom bit should be activated, top bit should be activated. Hence, now this is going to be 0, this is going to be 1. If I convert from binary to decimal, it is going to be 1. This is going to be 2. This is going to be 4. This is going to be 8. This is what values I can work with if I don't understand how this bits is going to work. And now if I talk about this, it's going to be 0, 1, 0, 1. This is going to be 0, 1 1 0, this is 1 0 0 1, and this is 0 1 0 1. And so now wherever the point is going to lay on this region, it should lay on any one of this region, and that region binary 4-bit value will be stored as your region code or the region bits. And so now we will see with an example how this is done. I hope you have understood how this is going to work and how we have divided this into 9 regions and what are the region code for these 9 regions. So now if I am going to have a point in this region, the 4 bits will be as 0 0 0, and if the point is going to be in this region, it is going to be 0 0 0 1 because it's in the left of your region window clipping region, and if the point is going to be here, it is going to be 1 in the right bit, and if it is going to be here, it is going to be the bottom bit, and if I'm going to have bit over here even at the edge, it is going to be the top edge. Yeah, just make a correction here. It should be 1 0 0 0. Please make a small correction here. Fine. And if I'm going to have the point at this point, I'm going to have 1 because it's top, 0 0, and even 1 over here because this is at the left also. Yes, the point is right now laying at the top left corner. Fine. So this is how we are going to assign the points or the region code for endpoints of any given line. Is it fine? So now we'll just see how this can be used to apply for this. So now for example, if I take the case 1, the line, the region bits for this or the region code for the P1 is 0 0 0 0, and even the P2 is 0 0 0, and for the line P3 and P4, P3 is going to be 0 0 0 1, P4 is going to be 1 0 0 1, and for this line P5 is going to be 1 0 0 0, and for the P6 is going to be 0 1 1 0. And now once you have got this region bits, my next step is, in this algorithm you need to check it out whether the line is going to belong to case 1, that is it completely accepted, or it belongs to case 2, whether it is completely rejected being at the one side of your clipping window, and whether it is going to be partially accepted being in the case 3. Hence at this outside, as an human, we can clearly understand this. This is case 1, this is case 2, case 3. But programmatically, your program should be trained. Your program should answer all the questions reasonably and logically. Hence that logical answer, whether this is going to be a case 1, case 2 or case 3, that logical answer will be obtained using the region bits of the endpoints. Now we'll see how this is done. Fine. So now if it wants to be in the case 1, that is if a line should be completely accepted, then the endpoint, the first endpoint Pi and the second endpoint Pj, I am going to take the region codes of this, region code of the first endpoint, region code of the second endpoint, and I am just going to perform bitwise OR operation. Perform the bitwise OR operation between these two region codes, and the result of this bitwise OR operation, if it is false, then we'll say this is going to be the case 1. The line should be completely accepted. If it is the case 2, then I'm going to take the two region codes of the two endpoints of a line, and I'm going to perform bitwise AND operation. And upon performing bitwise AND operation, if the result is going to be true, then we are going to say the line should be completely rejected. If this both the cases fails, automatically the line will fall into the case 3. Fine. So now we'll see how the case 1 is going to work. I am going to take P1 and the P2, and this is the region code what you already computed in the previous slide. So now when I perform bitwise OR operation, 0 0 is 0, 0 0 and 0, and if I convert this into binary value, it is going to be 0, and 0 is treated to be false in programming environment. Hence right now P1 bitwise OR will give me false, hence the case 1 is true. Case 1 is going to be true, hence the case 1 whatever we are going to have, this is what the line should be completely accepted. So now if I talk about case 2, if the case 1 fails, we'll go to case 2 now. So now in the case 2, we are just going to have these two endpoints. So now just try to apply the same operation for this case 1 using this 2 bits. Just try to apply for the case 1 is perform bitwise OR operation. If I perform bitwise OR operation, I'm just going to have 1 1, which is going to be 1 0 0 and 1. Hence I'm going to end with the value as 9, and 9 is treated to be true. Hence case 1 fails. In this, case 1 was success, but the case 1 is going to fail now. Hence I'm in case 2 now using P3 and P4. And when I use P3 and P4, when I perform bitwise AND operation, 1 and 1 is 1, 0 0 is 0, 0 0 is 0, 0 1 is 0. And when I convert this to a decimal value, it's 1 and it's true, and the case 2 becomes true now. Fine. And now this is how we are going to say the line is completely accepted or the line is completely rejected. And now just look at this case 3 where we are going to have P5 and P6, right? And these are the region code values. When I perform the OR operation, bitwise OR operation, you can just observe 0 0 is 0, 0 1 1, 0 1 is 1, 1 0 is 1. And when I convert it to decimal, I am going to get it as 14, and 14 is true, and the case 1 fails. Now if I talk about the case 2, where I'm going to have bitwise AND operation, and every bit becomes 0 now, because 0 and 0 is 0, 0 and 1 is 0, 0 and 1 is 0, 1 and 0 is 0, and the decimal value of this is 0, and 0 is going to be false. Hence even the case 2 also fails. When the case 1 and the case 2 both fails, automatically the line is going to be in the case 3. Now being in the case 3, now we will see what we are supposed to do. If it is going to be in the case 3, you are supposed to find the intersection of the line with the boundary and perform the clipping operation. That is what we'll see how it is going to be done. And now in this, I am going to have a line as P5 and P6, and I am going to find the intersection as in the case 3 using the region code as P5 as 1000 and P6 0110. So now we'll just see how this is done. So now once we are going to have the intersection, finding the intersection, we are going to follow this order. We will first check out with the left boundary whether there is an intersection with the line or not. Then we'll move on to the right boundary, and then we will move on to the bottom, and then we'll move on to top. That is the order what we are going to follow in this algorithm. And for this given line, we have got the region codes, and we are going to pick any one of this endpoint. Whichever the endpoint is going to be out of the region, we are going to pick that. If you observe, both the endpoints are right now outside the clipping region. Hence, I can pick any one endpoint randomly, but in an order, we'll pick it P5. So now we are going to have the P5 positions, and we are going to use the slope as M. And whenever we want to find any intersection, we are going to check out point outside at left. When I find there's going to be intersection of the line at the left boundary of your clipping region, this is the formula or equations what we are going to use to find the intersection point. So if a point is going to be towards outside of the left boundary, I am going to use this equation to find the new intersection point. That is, x will be equivalent to x minimum, and y will be computed with the phi intersection as yi plus x minimum minus xi into m, where m is going to be the slope of the line which is formed using this equation. And if the point is outside at the right, I am going to use x as x maximum. This is the equation what we are going to use. And if a point is outside the bottom, we are going to set y equals y minimum, and we are going to find the x intersection point. And if the point is outside the top, we're going to use this equation. So now first we need to check out, to use appropriate equation, we need to check out where the point is lying. Either is it towards left, towards right, bottom, or the top. So to do that, we are going to perform some logical operation. That is, we will take P5, the region code of P5, and the region code of left. So you are aware what the region code left is going to be at 001, and we are going to perform bitwise AND operation with this. So hence I am going to end with 1 and 0 is 0, 0, 0, 0, 0, 0, 1 is 0. Hence if I am going to end with 0, this is going to be false. Hence right now there is no intersection of the line at the left boundary of your clipping region. And so now if this is not as per the order, I need to now shift to the right. We'll shift to the right now. We'll shift to the right, and we are going to pick the region codes of the right and perform the same AND operation. So 0, 0, 1 and 0 is 0, 0 and 0 is 0, and 0 and 1 is 0. So right now P5 is not outside of the clipping region towards right, because P5 is outside the clipping region of the top, not right. Hence even this is going to fail. Hence so P5 is inside at the right. Compared to the right edge, P5 is inside. Hence that is why the false I am going to get. So next we'll check out with the bottom. If I check out with the bottom, again the AND operation will give me 0 zeros and this zeros, and even the point is not at the bottom side. Hence the clipping is not going to even happen over here. And now if I'm going to take at the top, and if I'm going to compute 0, 0 is 0, 0, 0 is 0, 0, 0 is 0, and 1 is 1. So now it's going to be 8 decimal value, and now it's going to be true. So when this is true, the point is going to be towards outside of the top boundary, and right now I need to find the intersection now. Clear? So now to find the intersection, I am just going to use the formula for the point which is going to be at the top. I need to set y equals y max, and the x should be computed as x equals xi plus y max minus yi divided by the slope. I need to find the slope using xi, yi with the first endpoint and the second endpoint as x1, y1 and x2, y2. Fine. And I am going to say y is going to be y maximum. Hence I am just going to find this intersection point, and now this part should be clipped out. Hence I am just going to clip out this part, and I am going to get this as a new line now. And once you get a new line, again you need to recompute the region codes. The region code for P5 has been updated now. The region code for P5 was 1000. Now it has been updated to be 0000. That means it is going to be within the region. It's going within the region. So now we will do the same operation. Now check out for the case 1. The case 1 is going to be 000, and I'm going to perform bitwise OR operation, which is going to give me 6, which is going to be true, and the case 1 fails. And the case 2, I'm going to end with 0, and it's going to be false. Even the case 2 is going to fail. And now still I am at the case 3. Again in the case 3, we are going to now pick the point which is outside the clipping region. So P5 is inside the clipping region, whereas P6 is going to be outside the clipping region. Hence we are going to take the left and the P6, again the same order. So left, right, bottom, top. And when I perform the AND operation, I'm going to end with 0, which is false, and P6 is inside the left boundary of the clipping region. And if I talk about right, and the P6, when I perform the operation, I am going to get it as 2. So P6 outside at the right. So if you observe P6, it's outside with respect to the right boundary. And so now I need to find the intersection using x equals x maximum and the slope and the values of x1 and y1. This is going to give me this intersection point, and this is going to clip out the line, the remaining part of the line, and this is what the new line I'm going to get. So now once you have got new lines, you need to find what is P5 and P6, recompute the code. When I recompute the code, I am going to get this as the new code 0000 and as well as 000 in this case. And when I put it to the case 1, when I'm going to put it to the case 1, so we are going to have the case 1 as, we're going to have the case 1 as, so P5, which is going to be 00, P6 is 00, and we are going to have this as 0, and this is going to be false. Hence the case 1 I am ending with false, and the case 1 is success, as this complete part of the line should be accepted right now, though it is partial line, but right now it is the complete line inside the clipping area. Hence this complete line which has been clipped with intersection should be accepted completely. Hence we are going to end with this algorithm. So this is how we are going to work with the algorithm of Cohen-Sutherland, and we need to continue this operation until we are going to have either the case 1 or the case 2, and this is the algorithm what we are going to use to perform the Cohen-Sutherland line clipping algorithm. So we are going to start. We're going to set the left value as 1, right value as 2, bottom value as 4, top value as 8. Then in the step 3, we're going to compute the region code for both the endpoints of a given line as C1 and C2. So if the xi, if the x value of the point is less than x minimum, set the left bit, and if it is greater than x maximum, set the right bit. Similarly the bottom bit and the top bit to compute what the region code is going to be. Once I am going to a region code for both the endpoints as C1 and C2, perform the bitwise OR operation and perform the bitwise AND operation. When I perform bitwise OR operation, if the result is going to be false, then the complete line should be accepted. I am going to display and I am going to stop. If I am going to perform bitwise AND operation and the result is going to be true, then the complete line should be rejected, and I will go at the step 9, reject the line and stop the operation. And if both the condition fails, I'll go at the step 6, so which is going to be the case 3. That is, the line is partially inside now, and choose the endpoint of the line that is outside the given rectangle clipping region. You are going to pick any one. I'm going to pick any one region codes, and I'm going to find the intersecting boundary edge by comparing or in the order left, right, bottom and the top. If intersection is found with any of an edge being outside at that boundary, we are going to compute and replace the endpoint with the intersection point, and we'll go to back to the step 3 immediately. We'll go to step 3. We are going to recompute the region code for the clipped line at the intersection point, and we are going to recompute this complete line. And if I don't find intersection at the left, we should repeat it for the right. If I don't find the intersection, repeat it for the bottom. If I don't find the intersection, repeat it for the top. At any one boundary, I should be able to find the intersection. If there was no intersection, then this would have never been the case 3. Fine. And so this is how we are going to recompute, and we'll be keep on performing this operation. We'll keep on performing this operation until either the case 1 should be true, the entire line should be accepted, or the case 2 becomes true, that is, I'm going to reject the entire line. Any one of this case should be true. Until that, I'll be keep on repeating this process. So once I'm going to have any one of this condition to be true, either I display and exit or I reject and exit. This is how algorithm is going to work. So now here is an example to solve. So now just try to apply this Cohen-Sutherland line clipping algorithm to solve this problem. Fine. So where you need to find what is P1 dash, what is P1 double dash, P2 dash and P2 double dash, and try to solve this problem and put your solution in the comment box. And if you have liked the explanation, so please comment, like, subscribe and share. And if you want the solution of the given problem, so let me know so that I can share the solution with you. And how exactly this algorithm should be implemented using OpenGL environment and C program, I'll be discussing it in the next section of my video. Thank you.